motion, it's always perpendicular to the surface, right?
We were learning in class about Newton's laws, and then we learned what a force was, and then we just do a bunch of practice problems. And then we had a quiz, which was very difficult, but I think we all learned a lot from that. And in the lab, we took a cart on a little pulley system and had weights on top of the cart, and then we had weights on a hook, and we had to do multiple tests, like where we were changing the forces and just seeing how that would change the time and how that would change the acceleration.
That unit was basically an introduction to forces and Newton's laws, which is a very fundamental thing in the subject of mechanics and physics. A lot of physics is inherently counterintuitive, so it's really important for students to not only be presented with the laws, but also be presented with examples for how they're applied. So hopefully that they can start to develop a process that which they can use to analyze these sorts of problems. So why I like to reinforce that process so much is it teaches them how to develop an intuitive understanding through very objective means. And I think it's important that the labs kind of come at the end of the unit, because that's when they're bringing all of their knowledge together to see how it applies in the real world.
First, we learn the concepts, and so there's a lot of taking notes, and we get kind of the basics of the process of physics, but then the labs kind of provide this space for us to see how they apply to real-world situations. The labs aren't just straightforward, they aren't directions. We have to figure out how to, based off of the knowledge we learned in physics class, we have to then figure out how to apply the concepts into real-world situations.
So, how much weight are we going to have on the cart controller?
This was a lab that was 100% trying to get them to understand not only Newton's laws, but also what is a system. And also, in terms of more general science practices, like how do you determine a good control? So what they do is they set up a cart on a track. I give them the cart pretty much already on a track. They also have all these various weights. Some of them are little hex nuts that they can apply to a hook that's attached to a string that runs over a pulley on the end of a track. And they'll notice that when they attach hex nuts to that thing, it'll cause the cart to roll and move down the track. Then they have other weights that they can put directly on the cart, and they'll find that when they place those weights on or take them off, that affects how the cart accelerates down the track when they hang those hex nuts as the weights.
We were trying to figure out how we could apply the equation, because the problem with it was finding out how we could increase the force without increasing the mass, and increasing the mass without increasing the force. So we figured out how we'd have to move stuff around, and you have to determine the right control in order to be able to do all that. And so our problem was, at first, I think it was trying to find where the force was coming from, like if the cart was applying any force or if it was all just the hook, and it turned out being all the hook.
This one required a bit of extra planning just because we had to set up each of the individual trials and see how we could affect the mass versus the net force on our pulley system, and also how we could just affect one, not the other.
They can realize that they can move weights from one place to another without changing the mass of the system, but changing the net force in the system. Likewise, they realize they can take weights on or off the cart, and therefore change the mass of the system, but leave the net force or whatever on those hooks completely unchanged. So it's this lab that allows a ton of freedom. But it turns out to actually complete the lab and do those 4 experiments, there's only one real control that actually works. So I love this lab because there's that first part of it, which is this puzzle. It's you got to figure out what control actually allows you to complete those other experiments. And there's no way you can determine that appropriate control without really understanding what does mass of the system mean. What is the net force that is actually acting on this system?
So I really like math personally, and that's probably my favorite subject, math and science, and it's just really cool to be able to apply numbers and math to figure out what's going to happen in the real world.
I think they did really well. I think they responded to adversity really well, because some of them definitely had moments where they're it's been a whole class period and we haven't even done one thing yet, or we've gotten all this data and all of it's garbage because our control wasn't good. And I thought they did a really good job at responding to that adversity and really thinking about how could they change things in their experiment to get the desired results that they wanted.